Hi, everyone, and welcome to the Laws of Exponents Part 2. We're simplifying square roots. So this falls into the category of exponents because remember we said that you can technically rewrite every square root, or we'll call them radicals because they're not always square roots. They can be cube roots or something else, but we can rewrite them as an exponent. So say this first one, I'm taking, well, 12 is to the power of 1, and I'm taking the square root. So technically this is 12 to the 1/2 power. So when we're simplifying a radical, what we're trying to do is basically take out as much as we can from the square root where we don't have anything left that can still be simplified. Um, so just some basic vocabulary, just in case, it's been a little while. This symbol is called the radical. The number that we call under the square root is the radicand. And if there's a number sitting out here, like a little bitty number, that is called the index or the degree that tells us what root we're taking. So if there's no number, then it's an implied 2. That's why we call these the square root. And if there's any number sitting out in front of your radical, then we call that the coefficient. All right, so let's try to tackle number 1. What we're going to do to simplify is I'm going to be using the strategy of the factor tree. And when I try to choose my two numbers to factor, I'm going to do my best to try to find the product of a prime number and a perfect square. And what that does is it already tells me that I'm going to be able to simplify something from my square root. So if it's been a little bit and you're like, what is this perfect square? A perfect square, remember, is basically when you take a number times itself and you get this number, that number is called a perfect square. So if you think about it, if I had a square with a side length of 2 and a side length of 2, that makes a square. So this is how we get that. So 3 times 3 is 9. I could go to 4 squared, but I know it's not going to be bigger than 16 because my number is 12. So I could start with 4. 4 times 3 makes 12. So I'm going to use 4 and 3. So here is my perfect square, and there's my prime number. 4 can be factored into 2 times 2. So since this is a square root, then I need groups of 2 of the same kind in order to simplify my radical. So basically what I'm doing here is I'm taking the square root of 4, which is 2, and I'm going to bring that out. And what I couldn't simplify was the 3. So he's just going to hang out inside the radical. But this is technically my simplified answer. That's as far as I can go. And the really neat thing is if you type that into a calculator, like if you did square root of 12 and you got that crazy long decimal, it would be the same crazy long decimal as 2 square root of 3. So those are the same answer. Just one is more simplified. All right, let's do the same thing with number 2. So here we have the square root of 125. So I'll keep going with my perfect squares. I already did 4 squared, so let's try 5 squared is 25. 5 squared, or sorry, 25 does go evenly into 125. If I multiplied 25 times 5, then that gives me 125. So again, this is all still under the radical. So I'm taking the square root of 25. And the reason I get 5 is because 5 times 5 is 25. So what's going to happen is the 5 is going to leave that pair. 5's, only one makes it out. And then what I had left was that other 5. So that was 5 squared of 5. And if you're wondering how would I write that as an exponent, so my original problem would have been written as 125 to the 1/2 power. If you're wondering how I would have written my answer as an exponent, the coefficient is 5, so he's going to be left alone. But instead of a square root, I'm going to use parentheses around that second 5 because the second 5 is the only thing being taken to the 1/2 power. All right. continuing on. Now we have some that are not square roots. And so we're going to have to think in groups of 3. So this is why I kind of like going back in those grouping strategies rather than just thinking, oh, the square root of 25 is 5. It's really, we had 2 5s. The radical told me that I had to have a group of 2 to exit. So here I'm going to have groups of 3 of a kind to exit the radical. All right, so let's think of this. If you're really good at finding cube roots times a prime, that would be great. um, Otherwise, we can just use like a prime number and its factor. So here I'm going to use 8 and 3 because 3 is a prime number. But the cool thing about 8 is that it is actually the number that I need. So the cube root of 8 is 2. If you're wondering why, that's because 2 times 2 times 2 is 8. So the 2 will become my coefficient. And then I'll have the cube root. So notice this time I have that little number, the index. And then what's left under my radical is a 3. So this would be my simplified answer. So again, as far as exponents, that first answer would have been, or the first problem would have been written as 24 to the 1/3 power. And if you wanted to write your answer as an exponent, my coefficient is 2 times 3 to the 1/3 power. So that's how we would write it. All right, and then our last problem, we are taking the 5th root of 64. So again, if you're just, you just know those 5th roots off the top of your head. Otherwise, I'm just going to start off with a prime number and multiply that times 32, which is what I need. So then I'll just continue my factor tree here. So I could start with 2 and 16, and I keep going, 2 and 8, continue on, 4 times 2, and 2 times 2. So if you look here, I had 1, 2, 3, 4, 5 2s. There's my group of 5, which means that that 2 will be able to leave the radical, and what I'm left with is that first 2. And I can't forget my index of 5. So here's my simplified answer, 2 the 5th root of 2. Okay, and then one more time for exponents. That first one would be 64 to the 1/5 power. And my final answer could be written as 2 times 2 to the 1/5 power. Okay, that is all of your laws of exponents and simplifying square roots. So if you guys have any questions, feel free to post them in the discussion board or send me an email as you guys are going through your homework. I am here to help, so please let me